Good morning. I hope we left enough seats for the people who are waiting for their Apple 6, iPhone 6. They're on the line up at the Madison Avenue store for Verizon and the Apple store. So thank you, Ellie, for asking me to participate this morning. And what I'd like to do before I introduce our first speaker on the panel is just lay down a couple of building blocks that I think our panelists, and maybe some even later, will be able to build from in the areas of the business, technical, and consumer aspects of what we're experiencing. Of course, my background is video and what's going on with video and the internet. Obviously, and many of these are obvious, people are viewing rapidly increasing amounts of video programming online. The vast amount of internet data that's being consumed is video programming. No surprise from a popular as well as a technical perspective. And traditional television creators, maybe less CBS than the others, and distributors are implementing internet distribution strategies, and many of them are emerging to be what appears to be quite successful. The new entrants in the internet video aggregation business and distributors are succeeding. And obviously there'll be shakeouts, but that's not a surprise. Technically, video distribution is moving from a traditional multicast or broadcast model, which is from one to many, to the internet-based unicast model. However, the latter is significantly more expensive. And because of that, video distributors and network architecture suppliers are seeking structure and methods that will lower the cost of unicast, lower streaming and edge storage cost among that. ISPs and cable and in some cases telcos are reallocating their bandwidth to stay ahead of the internet data demand curve. Cable is even building massive interconnected outdoor and free Wi-Fi capability. Something, just as an example for those who are not from New York, but one of the New York cable suppliers, Cablevision, has built 1 million Wi-Fi hotspots that are available to their subscribers and any other interconnected cable subscribers. If they are to remain relevant, wireless networks are going to need additional spectrum and architecture, new architecture and changes to their architecture if they're to remain as viable ISP options. And from a consumer perspective, while tablets and smartphones have provided portability to video consumption, the data shows that most viewing on these devices occurs in the home. And long-form viewing, half-hour, one-hour television shows and longer, are primarily using larger screen devices, no surprise. And because of that, the number of connected devices within each home is growing geometrically. So with more devices, home viewing is increasingly individual as opposed to a group family setting, with family members watching and doing different things and driving up the bandwidth demand. Lastly, and this might be somewhat controversial, but there is a public policy question. About 85% is reported of internet viewing data is being consumed through the very small segment of spectrum that's allocated to Wi-Fi. And only a small amount of data, internet viewing, is flowing through the large and growing spectrum that's allocated to cellular. Something that I submit may need to be addressed in the future. So I offer these items as an underpinning for some of the discussion that's going to follow. And I'd like to begin by introducing our exceptional first panel. And we'll follow the order that's in the agenda. And first up is John Carey, who is Professor of Media Management and Director of the Center of Communications at Fordham University. John?
Thank you. then it's left. Okay. Okay. Well, good morning. Very happy to be here. I'm kind of a. I think the panel members are going to come at this topic from different perspectives. My perspective is kind of where this video technology is going and the consumer. Because what I do, I'm sort of a media anthropologist. I go into homes, I go into offices, and I observe what people are doing. So I want to pull out some of the lessons from what I've been doing in my research. And I'm going to go through this pretty quickly. First obvious one is who's going to be the early adopters for this stuff that we're talking about. This is a cartoon from the 1980s, and guys saying, you know, all my gadgets are old, I'd like some new gadgets. And this was the early adopter 20, 30 years ago. It was a guy, 40s or 50s, had a lot of disposable income, but it's changing. The early adopters now are much younger. They are willing to spend a lot more of their income as a percentage on technology, and they're the ones we have to really pay a lot of attention to. Second general issue is this new technology ready for prime time? And think about the evolution of, say, the cell phone. And we're talking about video on phones. Well, the early ones didn't have any screen at all, and then the notion was to get smaller and smaller, but that wasn't very good if you were looking at a display. And then we're coming back up. And one of the big issues, and I'll get to this even a little later, is what screen size? Is there an ideal screen size? There are going to be multiple screen sizes. That's a huge issue, I think, right now. Another technology that was not ready for prime time, the early HD TV sets. This set was a rear screen. It was like 5 feet deep. It occupied a quarter of this room in Yonkers. And you were not going to have HD TV if this was the technology. And here's kind of a cartoon about it, you know, how you hide it. So it wasn't ready for prime time. And then lo and behold, we get the flat screen, which was essential for this to become massively adopted. 3D TV, basically it's dead. It may come back again without the glasses, we'll see. Mass market or niche, this is the other thing that's really important. As we talk about these new technologies, is everyone going to have it or just some? One example, Oculus and this Oculus Rift. And I know people who were saying, everyone is going to be watching television with one of these devices. Really? I can certainly see it for gamers, but the idea that the average, member of the public is going to be watching television this way, I think not. I think it's much more of a niche thing. This is what it looks like. One company said, well, maybe we put mothballs on the top of it, it'll be attractive to women. No, I don't think so. And Segway, I want to use Segway as an example because we also have to be very careful about hype. If you remember when Segway was introduced, it was going to change society. There weren't going to be any cars in cities anymore. Everyone was going to be on a Segway. Well, no. Segway has found some niche markets, security people in a mall, tourists, who are going to take a little tour around parts of the city, but it was niche, not mass. Virtual reality, we're probably going to hear a lot about this. And it's been a big thing, certainly in the gaming world, but also an enormous amount of hype about this that Second Life was saying, we're going to have to change the Constitution because everyone's going to be living in this virtual world. Well, it hasn't happened. Will the new environment support it? Maybe. We'll see. How many screens? I'm looking at this is what everyone is talking about. We saw Ellie's picture, the traditional television, one TV, everyone's gathered as a crowd to watch it. And now, is it 2 screens? Is it 3 screens? When I go into homes, this is very, very common. People have the regular television on and a second screen. But it's more than that. Sometimes, look at the age of this woman. And she's got a TV, she's got a laptop, she's got a smartphone, using all of them at the same time. I see this everywhere. But it's more than that. I don't know, the screen's a little dark here. But there are 4 laptops and the television. It's 5 screens in one room. And this is sort of an illustration showing that in many, many homes, you have a family watching on 4 or 5 different devices. Okay, when people wear technology, we're now in a different realm because a lot of these new things, you're going to be wearing them. So where do you start with this? Well, I like to start with the pocket protector. And what I'm getting at is it's a symbol of who you are. This was, back in the day, engineers were so proud of their pocket protector. It said who they were. Others thought it was nerdy. And that's where we're going to get into with a lot of the new technologies. Is it fashion and wonderful, or is it nerdy? Okay, here you'd see someone with things hanging off their belt. Very common. People sometimes will hold a cell phone this way. This woman on her boot. You know, it invites this question about fashion. Now, let's come to Google Glass. Is this your image of the Google Glass user, this fashionable young woman, very fast, making a fashion statement, or is it this guy? And then, of course, the new Apple phone, rather watch, that's going to be really interesting because once you get into wearing something, you have to ask questions about, is it fashionable, and what kind of a personal statement is the technology making about you? Okay, very quickly, public location media. We don't think about this so much. Technology is everywhere in public places. I'm on a bar in San Francisco. Okay, 1, 2, 3, 4, 5 people all have electronic devices. New York City on a subway platform. Typical college dorm situation. This is a car repair place and television everywhere. Lounge in Istanbul, multiple TVs. So the whole notion of what do you do with technology in public places? Okay, transitions, also important. We've seen the transition from the desktop to the laptop, and now laptop use is going down to the tablet to the smartphone. And this seems to be continuing. Changes in how you use a device. Well, all right, let me show you something. I go to, oh yeah, I'm fine with that. I'll be done in less than that. I love to go to graduation. It's so much fun. And I take photographs and we post it on the website. So here we are in 2008. And students, before the graduation starts, they're all on their cell phones and they're calling a parent who's over on the sidelines and they're waving. I'm the guy waving. Okay, now we come forward a little bit. 2013, they're all texting. Now think about the changes in the use of the cell phone. From voice to text, it's been enormous. I don't think I make 10 telephone calls on my cell phone a month, but I'll text all the time. And that's a dramatic difference from what I was doing 3 or 4 years ago. Well, all right, now let's start asking about video. And once again, back to size. They're starting to use this term phablet. What's the right size for this device? We wanted it as small as possible so it could go in our pocket. Now we want it bigger so we can watch video. But how big? Okay, complexity. This is one of the things we've got to watch out for. Because everyone in this room, no matter how you classify yourself, you're way more advanced in terms of technology than the average person. Okay, this is a coffee table in a house. If you count the number of remotes, it's 9 remote controls. Okay? And the guy who I'm interviewing at this point is proud as can be. All the devices he can control. And his wife, who's standing just to the left, says, I just want to change the channel. And which remote do I pick up to change the channel? And that's where we have to be really careful about going too high-end if we want to reach the mass public. Okay, gimmicks. There's a lot of gimmicks with technology, too. My favorite historical example is the highway hi-fi, introduced by Ford in the 1950s. Now, it's a phonograph, and they put a phonograph in a car. I mean, what were they thinking? And it didn't, of course, it didn't last. You know, but we've always had these things, you know, Elvis Chia, you know, but be careful of the gimmicks, something that doesn't really have any real audience. My recent research, if people want to get paid with this stuff, all right, passcode sharing is rampant. Try to find a 20-year-old who is not using a passcode from either another friend or a family member, you know, parents, to get onto HBO Go, as you see here. Okay, looking in the dustbin for applications. A lot of things that failed come back because you fix it. My favorite example, picture phone, introduced in the 1960s. Failed. and introduced every decade after that, failed. Okay, and then Skype comes along, and Skype is adopted by, millions of people. Why? The laser video disc, a huge failure. 10 years later, it's the DVD, the same technology, only it's better. So sometimes we can look at the past and say, all right, that failed, but I can now fix the reasons why it failed. Another example, Yak Live. This was an MTV, and what they did was they let people go into AOL and type anything they wanted, and then they put it on their national feed. And it was a disaster because people said, this is idiotic. But then come forward on Twitter, on Facebook, you're now doing it with friends. Much better. Okay, so they fixed the problem. Surprises. Have you been following what's going on in esports? There's this thing, Twitter. Twitch, it's Twitch. They're getting audiences like A&E, a couple of million people at night. They had 11,000 people in a stadium watching people play video games. Okay, forgotten generations very quickly. Older baby boomers. These people have money and they have technological savvy, much more than you might think. But the industry doesn't recognize it. Small children. This girl, I interviewed her it was 3 years ago, and she was incredibly into toy cell phones. I just went back this fall, and she's now 6 years old. She has a phone. She's the tech support person for the entire family. She's 6 years old. And I've seen kids 4 years old, complete control of iPads. Okay, and this is sort of capturing that. All right, my last thing, Chipotle TV. I'm trying to metaphor. What I think is going to happen is, it's still the case, most people get their television from one source, say cable. What they're starting to do is assemble it, almost like in Chipotle. I'm going to get Netflix, I'm going to have maybe basic cable, I'm going to get this, I'm going to get this. Not infinite choices, but a number of choices that you put together yourself. With that, it's about content, not the technology. And lastly, why do people watch TV? Let's not get too high-end here. It's all about entertainment, it's about relaxation, it's about escape. And that's not going to change no matter how you change the technology. Thank you.
Thank you, John. My grandson, who's 12, just told my wife when she asked him to help for some help with something technical, and he said, well, that's what grandchildren are for. And he was very happy to provide that. You should know that we made an overt decision at HBO to not try to stop credential sharing, and it's been very, very good for the business. So, in any event, we're going to ask you to hold questions until all the panelists are presented, and then we'll hopefully have some time for that. So, next up is Greg Harper, who is president of Harper Vision, and Harper Vision is a business technology development firm. Greg?
Good morning. So I am the guy wearing Google Glass. I have the Motorola watch, the Samsung watch, the Nike Fuel Band, Fitbit, and a few other things on me. And yes, I do have the phablet and the iPhone and the Galaxy S5. So I live this. So while you go and be an anthropologist, I, in fact, live this on a daily basis. And I'm just going to go very quickly because I'm, in fact, saying the very same things that you are in here. But I'm going to take a little different tact, and that's the creation of content. I was a television producer for many, many years and moved into new technology now. But basically, in the old days, and tell us when old is. I guess Bob and I sort of qualify in the older side of things. TV was produced by big media. We're all members of an exclusive club, and that required a fairly expensive equipment. Broadcasting was done by cable network, satellites, etc., and it was all a very closed club. Production didn't change very much. Whether you're looking at the Beatles coming to New York and the control rooms in black and white, we got nicer cameras and nicer control rooms, but it was still the same thing. We were still using it, still a member of the club. TV viewing, there's the same photo as there. We're all watching TV in a group. It's now gone to watching TV in a group with a bigger screen. But the internet is changing TV. This is the copy of Business Week just a few weeks ago, and it's talking about the YouTube generation. And what is important to see is how video is dominating the global consumer internet traffic. This is a slide from Cisco. That's petabyte usage per month over 2010 to 2015. Take a look at that graph going up there in the corner here. And I guess my battery died on this thing, which is, that's the only problem with technology is if you don't have the battery, it doesn't work. So as you can see, the curve is going up. And it's soon going to be that the video traffic, to Ellie's point earlier on, is going to be dominating the internet as we go forward. And the other thing that's happening is the new normal. It's now Hollywood is moving. This is Hollywood, which used to be suing YouTube, trying to do everything to stop them, is now joining them in spades faster and faster and faster. It's creating new channels. So you've got these are just YouTube channels. This thing is growing by leaps and bounds. But interesting, it's not the long form anymore. It's a 6 or 7 minute thing, and it's being produced by people who are just everyday people who are creative because they don't have to be part of that club anymore. And internet TV is replacing linear TV. We know that. This is, again, the same thing you're seeing. Everybody's sitting there on their own device. There may be a screen running around the background. There may be something common, but everybody's watching it on one of their portable devices. What's driving all of this? Well, bandwidth costs are declining. So the bandwidth costs are going down and down and down. Storage costs are going down. And, of course, the cloud is rising. This is from Mary Meeker's presentation that she does every year, and every year I see these numbers changing dramatically. But that's what's happening. Amazon Web, Ellie mentioned that a little bit earlier today. So let me just go over here to over back where I was standing, because I did bring some props, figuring that sometimes you hear about this stuff and you see it. As I say, I like to actually live it, and so let me just put it into perspective. Television production has dramatically changed. The video production switcher that you see there, the video production has changed dramatically. What used to be one ME switcher for video production, $35,000. Well, guess what? This is a complete television studio switcher system. It's not just a switcher, it's a multi-viewer, it's also a graphics generator, it's a DVR, it plays video, $999. This is a full HDSDI, full 4K, believe it or not, capable production switcher. That's $1,000. So dramatic changes have happened on that front. The same thing, back when I was doing television, we recorded TV on this Betacam SP. This is the size of the tape. Imagine how big the deck was that ran it. The deck was not only big, but it was also expensive. And if we wanted to broadcast, we needed a mobile truck. Today, the whole thing fits into an airline flight bag. This in my bag here is not only the much more storage than that in digital at much higher resolution, but a full broadcast package. What does that mean? Well, for storage now, I have a couple terabytes of storage on a little rugged drive. Much more information on that. We'll store 4K. The video recorder is now this little device here. You plug in HDSDI, you connect that to this, and out comes broadcast quality video. And if I want to broadcast it, and the gentleman in the back of the room is using the same thing, I take this, I flip this little thing like this, plug it in there, and here is my mobile truck. You connect the output of that switcher or a camera to here, and I'm now broadcasting live. Thank you very much. This is a wireless network, and that's even assuming I'm in the middle of nowhere, as opposed to here where I have Wi-Fi. I'm broadcasting. Of course, acquisition. We've all seen all the YouTube stuff and all the rest. A lot of it's being done. You want to borrow it?
I could borrow this. I have one over there, and it's not working due to
So we all seen the GoPro. This company just went public recently. High quality video. If you saw the broadcast from NBC News after they were doing the Situation Room when they were looking at the takedown of Osama bin Laden, and they had a very small room and they had big broadcast cameras. If you look carefully on the table, there were like 5 of these little cameras on there. That was being broadcast on NBC National. No one knew it was coming from that. It's not only that. Super 16. It's a format, many thousands of dollars. Here you go. Here's a full Super 16 camera. Cost about $700. But of course, that's nothing compared to other technologies coming along. This is a multi-headed camera. Notice all the lenses. This thing has 6 lenses. I have the 6-lens version here. Unfortunately, the 12-lens version of it is back in my office. It records a 360 image because there's no longer a screen aspect. And of course, we've talked about 4K and other things like that. I mean, 3D and other things. 4K is coming. This is a 4K broadcast camera. Thank you very much. When I was doing 4K 4 years ago, the cameras cost me over $100,000. Had to have them specially made in Japan with export permits. I can buy this now at the corner store for $1,500. And yes, it does do gorgeous looking video, and it's all, of course, stabilized and high quality. So there's a lot happening in the production of stuff. But it's not just the production, it's also the consumption of it. We all talk about how we consume on our phones. You have tabs. This is the Amazon Kindle Fire. This not only will allow you to watch a very high quality picture, but when you get home, it'll automatically transfer to your TV set, and you control it with your voice. So no more remote control. You just say, "I want to watch a particular show," and it will actually find it. This is what's happening in graphics is happening very quickly as well. This is the NVIDIA Shield. I don't have time to turn these things on, unfortunately, but this thing is a high-end graphics card. When I was playing with graphics creation, this type of thing would have been a $50,000, $60,000 computer. This has high-speed GPUs on here. This will render in real time, and it will output, of course, in full broadcast. But it's not just that. It's also going to the home. Of course, we all know Apple TV. Plug it in and make it work. We've gone to other technologies like Roku that plugs in, acts as a broadcast capability. But this is a media server. This will store about 10 full quality videos, movies. You stick it in your bag, put it in your car, and now you're being your own media server, your own mini HBO Go for you right in your pocket. Have it along with you. Now, if you don't like that system and you want something a little bit more involving, of course, you can use Google Glass to record, or you can do a hybrid. These are the Epson glasses. I guess I can't wear 2 sets of glasses at once. These are the Epson glasses. So I can still see through here, but it's a total 360 experience. And it's, of course, motion tracking, and I can watch a full high-quality image superimposed on top of you all. So I can still see you, but I can also watch the video. But then, if I really want to go further, we talked about Oculus Rift. Yes, it may be a gimmick, but this is what it looks like. It is. I can't see a thing, but I'm in a total virtual world. And for gaming, it is really quite amazing. It's fascinating watching people use it and get dizzy and start falling down, which is interesting. But what just happened, which is interesting, is our friends at Samsung have teamed up with Oculus, and they've put a smartphone in so it's a self-contained unit, and they're now actually running 3D. Well, actually not 3D, I would call it 360 3D immersive videos where I'm sitting in there and I'm able to actually be in the content. And I can do that and I can shoot that with a camera like this. So these tools are happening. These tools are making it all possible. And I just want to give you a quick briefing on this. I could talk on for hours and hours and hours. If any of you are interested, come visit my lab over on the east side, where I watch TV from all different sources on a 170-inch screen in, of course, full 4K. Thank you very much.
I don't know if it's for me to say, but I just want to give everyone a bit of advice. If you ever see Greg in the airport at the TSA security line, just give him a wave and go to one of the other lines. Okay. Next up is Qian Hua, who is the Pegasus Professor at the University of Central Florida and Director of the Data Systems Laboratory. Qian?
Good morning. The last two panelists focused a lot on devices, so I will focus mostly on the bandwidth, the internet communication issue. So these are the topics that I would like to discuss today. First, I try to scare you a little bit about the problems and future problems, and then we try to understand exactly what caused those problems and maybe introduce some of the possible solutions to address these challenges. So why Netflix is slow? So customer must get what they pay for, and one possible solution maybe for the content providers to have some deal with the internet service providers to improve their services. But should they pay for that? Some concerns is danger of slow lands on internet. So I guess everyone talk about the net neutrality topics, and it's certainly that this is an important issue, and obviously, we have 1.5 million comments on the recent the FCC request for comments from the public, and there certainly is a lot of interest on these topics here. But are there less controversial technology solution? So those are the policy issue. Are there technology solution? That is what my focus today. Why Netflix is slow? Video streaming dominates the internet. We have heard this over and over, and by the 2018, actually, 80% to 90% of all traffic would be about video. And another observation is that the 80-20 rules. 10% at YouTube, 10% of the most popular videos account for 90% of the total requests. So with these two observations, what we see is not only that most of the traffic on the internet are videos, and actually most of those traffics are for a few of all the video that we request. So with those two observations, and we can say that the internet is slow, partially due to significant redundant traffic. Right. So most of the requests for the same thing, and then the providers can just repeatedly send out the same information over and over again on the internet. As a result, we have all kind of redundancy. So the idea is deduplication. If we can remove the redundancy, then suddenly we have a lot of extra bandwidth that we can support more services. So that's the idea. But how do we do duplication? So we need to think out of the box. The conventional wisdom is that traffic congestion is bad. We don't want congestions. So when we do the routing, we try to avoid congestion. And if there is congestion, we must have a way to get around it. So that's the conventional wisdom. But the proposal here is that traffic congestion is good. Why congestion is good? Because it's actually this facilitate duplication detection. Unless you have the congestion, they all come to the same place. You cannot detect duplication. And once that you detect duplication, then you can do data sharing, and that's how you lower the bandwidth consumption of the internet. Okay, so that's the idea. So how do we do that? Some of the router that we developed is called the smart routers. So this is the first stream S1 for a particular request. And sometime later, we have another request for the same videos, S2. And the two actually requests for the same videos. Then the data that you stream to this router for the first stream, you can buffer it and reuse that later for the other stream. So that way, we can reduce the stress on the internet. So that's how we can conserve bandwidth for more services. Think about this way. These are the routers. And we have two streams for two different video requests that going through these routers here. And if that router had intelligence to merge the stream as we see it here, now this merge here, then initially we have independent stream, but dynamically over time, the streams start to merge, and then eventually that you see it here is a single delivery trees. It requires only a single server source, but it serves many, many consumers. So without these ideas, now this is what we do today. We will have many, many streams, and this can become a bottleneck. And when this becomes a bottleneck, basically you cannot use the router down here. So you waste all the resources down the stream. So you relieve this bottleneck as we see here. Now we can make good use of the resources downstreams. And more, now you see it here, we have a lot more traffic here and so much less traffic here. Right. So that's the ideas. And this is what we do today. We heard before that we must rely on multicast. Multicast is one-to-many, that's broadcast. And that is less expensive because people share the same video streams. However, this is not on demand because you have to wait until the multicast time. So what we really need is something like this. It's still like multicast, it's still a single video source, but the consumer does not have to be at the same play point in the video stream. So this is not one-to-many, but it's not one-to-one unicast either. This is a new paradigm. This is something in between. So you do not have a lot of demand on the server, but you all do not have to wait until the multicast time. You start whenever you want, and you can come later, still join the same stream, but you can start at a later times. And that is what that smart router can provide you. So today, how do we do duplication? How do we know the two streams is the same? One way today that we can do is that if two streams come from the same URL, right, then obviously they're the same. But the limitation is that the two video streams might on two different servers, then they do not have the same URL, and therefore we would not know. So the benefit from duplication detection will be quite limited. So a solution is that we can introduce some kind of content identifiers. So if two streams, regardless of where the URL, where they store, as long as they have the same content identifiers, we say that they are the same. So that would be one way that we can address the problems we have today, that the internet is kind of slow. Another thing that looking forward, nowadays most of the communication on the internet is by humans. We watch Netflix, we send email, we make Skype call. But that is going to change. There will be many things, invasion of things. So the things here can be cameras, can be sensors, and there will be many of those. By 2020, there will be 28 billion. So no human being will not be watching a video on demand, will not dominate the internet. Things will dominate the internet. Okay, and it's really bad because we watch movie only maybe a couple hours a day, but things they constantly, continuously sending out the video. So we're talking about 20 billion continuous streams by 2020, and so we will be dealing with a big data. Sorry, not bad data, big data, and this is actually incompatible with cloud computing. We cannot have cloud at one end and all the things out there and wait for them to stream video to the cloud and do computation. We will flood the internet, and that would be really bad to the video entertainment industry. So what we really need to do is that we need to make these things smarter. So we need to introduce some kind of interface. So we need to have a query interface. So instead of get the data back here and do all the processing here at this farms here, we have an interface that we can query. So we specify an event, and then only when the event is true, that's when we need the video. Otherwise, we don't want things to flush the internet with videos. Okay, so that's how that would be more responsible way to use the internet. So I'll skip this one. So in this thing ecosystem, we will have here we have the thing providers that provide the things, and they also provide those smart services that provide the event detection. So you can say if someone appears on that street, kind of an issue that you just use that as examples. If someone appears on some street, then I want to know about it. Otherwise, they do not constantly stream the video to me. And then another category of user would be the app developers. They can develop application using all these things here. So this is, you can publish, just like you would publish a web page today. Here, it's not the difference here, you publish a things, and you can publish application, and finally the end user who make use of those apps. So to wrap up, to ensure fairness, that's about policy issue. So net neutrality is an important issue that requires attention from the technology point of view. To improve the current internet, we need to remove duplication. There's just too much of it. So by doing so, allow more streaming services. And in the near future, then we have to cope with the invasion of things. And a poor IoT architecture can have a profound impact on the management. I think that can provide a potential architecture for a more responsible IoT deployment. And as our research, both traffic deduplication and EQL are still in the research stage. So, but nevertheless, the initial results are encouraging.
Thank you, Kent. Some food for thought, some interesting thoughts to consider, but maybe also to debate. And we'll have time for that. Next up is Yale McGuire, who is Engineering Director of the Connectivity Labs at Facebook and visiting scientist at Harvard. Yale?
Great, good morning. It's great to be here. So even though I work for a company that spends a lot of time doing video, I'm actually not going to spend too much time talking about video today. It's somewhat of a different topic, which is really about trying to think about how to connect people to the internet in general and people all around the world. So the company mission at a fundamental level is to figure out how to make the world more open and connected. And we believe connected really literally means connectivity and how we get people online. So we have started an organization called internet.org, which is focused on inclusion from an internet perspective. Our goal is to figure out how to get every single person online. And what we are trying to do is to figure out how to do that from multiple perspectives. So the first thing is just some background data about connectivity. So the first one is that by the end of 2014, the ITU is predicting that 60% of the world's population will not have any access to the internet. Delving into that a little bit more detail, you have to look at what connectivity means from a physical perspective. So this is a map that we've constructed based on our own data sets of our 1.3 billion users that connect to the internet through towers all around the world, except for places like China. And so what you can see is red represents at least a 4G signal, so that can include 4G connectivity or LTE connectivity, which would provide levels of connectivity that would be appropriate for viewing content like HBO Go and things like that. And you can see that this is restricted to US, Canada, good parts of Europe, and then the eastern parts of Asia. And then blue represents basically 3G or 2G connectivity. And that really is the majority of the world. So you can see that there are large swaths of the world that just do not have the type of connectivity that would support any type of video services or any type of rich content that we take advantage of every single day. And we don't think this is going to change very quickly. So the majority of the world does have access to a 2G signal. It's roughly 85 to 90%. Those estimates vary depending on who you talk to, whether it's an Ericsson or the ITU. But there's still roughly about 15% of the world that has no access whatsoever. If you gave them a cell phone, if you had a mechanism to do that, they wouldn't have anything to connect to. There's no physical infrastructure whatsoever. So our focus is on trying to figure out how to connect every single person. That's our goal. It's very bold, very ambitious, but we think that we need bold, ambitious plans so that we can try to figure out how to do things differently. So we have one part of the organization within internet.org that is going to focus on how to work with operators to figure out how we can connect all those people that have access to those types of signals, but the focus for the connectivity lab is to figure out what kinds of things can be done to connect those 15% of people that have no access whatsoever. We think this is a really interesting testbed to think about how to develop new technologies. You could ask the question, why does connectivity itself have to be a research problem? In principle, all the technologies exist today to connect everybody, but it's just not economically feasible to do that. And so I want to try to give you some insights into that, and I'll just come back to the data itself. So this is some data that we collected that actually comes from Columbia University. So thank you for creating public data sets of population demographics for the world. This comes from the gridded population of the world version 3. And allows us to do some really interesting insights into how and where people live. So the biggest thing to understand are power laws, and connectivity, especially wireless connectivity, has to do with putting information in space, and different technologies are going to have different ways of distributing information in space. And so since we're ultimately focused on how we connect people, we have to understand where people are on the planet. So the first thing is, so what we did was we took this data from Columbia and try to calculate where's the density of people as a function of area. And so the first thing to note, this is the scale actually goes off the charts. It actually goes up by a factor of 6.7 off of this. Each little bar represents 1 million people. So this is the scale of 10 million people here, and we see, just as sort of points of reference, San Francisco about 1 million people, Mexico City 9 million, Lagos, Nigeria 17 million people. We see a power law distribution. So for the first 20% of people, or the last 20% really from a connectivity perspective, they actually take up 85% of the land area of the Earth. And then the next 20% takes up a much smaller fraction until you get to the last 20% takes up 1% of the land area. So from a 1% land area perspective, and you think about laying fiber and putting up towers and things like that, that's, you know, a challenging problem, but at least tractable, because you know you're only dealing with 1% of the Earth's land area. But if you're trying to connect everybody in the world, you have to deal with the fact that the last 20%, and you know, we think roughly 15% of people in the world are in that last 20%. It's a really daunting challenge to figure out how to do that economically. And so that, for us, is why there's a research problem to figure out how can we do this in an economical fashion. From our perspective, we think that in order to do this, we have to improve the cost of connectivity by at least an order of magnitude relative to anything that exists today. So in terms of areas of interest, these are specific countries and regions. Largest percentage of people that are unconnected. You take a country like India, and the 7 here, close to 1.2 billion people, 1.1 billion people have no access and are not connected to the internet. All the countries that are listed here, while not in absolute numbers, have the same number. They have a significant proportion of people that have no connectivity whatsoever, so they're not enjoying all of the benefits that we all see in the internet today. So rather than focus on the wireless technologies themselves, there's a tremendous amount of innovation. Hundreds of billions of dollars are being spent by engineers looking at how to figure out how to wirelessly connect all the devices that we have. We're focused on platforms. If you imagine today a base station, a 2G base station, can cost roughly around $30,000. If that were to cover 30 square kilometers, you're basic, and you have only 30 people per square kilometer, which is the reality of given those distributions, you can spend up to $1,000 per person. It's just not economically viable to use a terrestrial base station to connect people in these types of environments. So we're looking at different architectures where you take the base station, instead of trying to connect to it on the ground, you actually lift the base station into conventionally what is space. So satellites are a very common mechanism to do that. But we think there's lots of other platforms that need to be explored to figure out how to dramatically reduce the cost of connectivity. So we're interested in different types of satellite architectures. We're also interested in planes, and that's what I want to give just a little glimpse of today. So why planes? So one of the things about flying something in the atmosphere as opposed to space is that planes are, in principle, compatible with terrestrial protocols. So for example, the LTE standard, which is probably communicating with all the phones we have in this room, is designed to work up to 103 kilometers, which is well within the airspace envelope that we're hoping to use for these plane architectures. From a physics perspective, we're looking at plane architectures that fly above commercial airspace, so about 20 kilometers up to about 30 kilometers. If you relate that to a geosynchronous satellite, it roughly is, from a power perspective, 3.2 million times better. But similar to a geosynchronous system, you can put the planes exactly where you need them. So if there's a small community that's remote in mountains in Bangladesh, you can connect and place that capacity where you need it. And the other interesting thing is when you put something in space, you can never service it, but a plane you can just bring back down over time and do that. So, but this has enormous technical and regulatory risks. I'm not going to spend too much time to talk about the regulatory side of things, but this is a type of risk that we're willing to trade off to try to get those benefits. So we're doing a lot of analysis, also thanks to this data from Columbia, to try to understand how would you allocate resources to optimally connect people for the lowest cost. And so this is just giving some example, but also just to show you the sort of differences that you see across different countries. So on the left is India. Green represents what you would do if planes existed. Blue is terrestrial, and yellow is satellite access. And then Brazil, for example, very different population density distribution in the country. The majority of the country needs to be connected via satellite. And so there's no silver bullet for connectivity. You actually have to consider multiple solutions at once. And so we're actually going to pursue those all in parallel. So just as an example of the autonomous plane platform that we're working on, it's carbon fiber airframe. It's fully autonomous, solar powered, and uses propellers for propulsion. The altitude that we're looking at is between 60,000 and 90,000 feet above all commercial airspace. There's no regulations for how planes can operate at this airspace, so it's new territory, but one we're willing to explore. The plane has to be able to operate in the air for over 90 days. So the key thing is there can't be any people involved, even though I'm showing a person here to give you a sense of the dimensions. And this is just exemplary. This is not the actual plane we're building. But it's about 75 feet in width, so roughly the size of some commercial aircraft. But so, you know, if you lined up 5 Toyota Priuses, that's sort of to give you a sense of the size. But in terms of mass, it's the size of the 4 wheels of a single Toyota Prius. So just to give you a sense that you have to take people out, you have to think very differently about planes flying for months at a time to be able to make this work. So that's just an example of one of the types of platforms that we're looking at to try to think out of the box for how we're going to try to figure out how to connect everybody on the planet. So thanks very much for your time.
Thank you, Yale. This reminds me of in my youth when we were thinking about how to take television beyond the 200 DMAs in the United States and wound up using satellite. So we have time for a few questions, and so I'm told we don't. And if you just raise your hand, Bob, we'll bring a microphone to you.
Yeah, Robert Pepper Cisco. Hi, Yale. So question, you talked about the 15% that didn't have coverage, but you talked about India with 1.5 billion people who are not connected. So is it coverage or not being connected? In other words, I'm trying to understand, so the problem you're trying to solve with the plane are the geographies that have no coverage. That's different than in India where you have coverage, but you have 1 billion people who are not yet connected, right?
Yes, that's a very good point. So the Connectivity Lab is going to focus on the 15% that have no coverage whatsoever. Internet.org overall is going to focus on everybody. So the 1.1 billion people in India, that is going to be the highest priority for the organization. The Connectivity Lab is going to focus on the 15% that have no access. We want to start there. The hope is that if we can figure out technologies which have a significant impact on the economics of delivery, then those can be brought to bear on those that do have access but maybe need a new mechanism for that.
Thank you. I'm Heather Hudson and I'll give you an example from Alaska in a little while, but also a question for the last speaker for Yale, and maybe related to Bob Pepper's question. There aren't really that many places in the world where coverage is a problem. If you looked at most of the places that are targeted on that map, you would see that there are satellites covering them, or in some cases some terrestrial, but the connecting people up is a problem. Where there are places that need that perhaps are South Pacific Islands, some really isolated offshore locations where connectivity just isn't available. I mean, there's satellites covering all of Africa too. The kind of part that you ignored, the regulatory risk and the economic risk, that's where the real problem is for most of the areas shown on your map, which isn't to say that there aren't some that could benefit from more creative and low-cost coverage solutions.
Yeah, I totally agree. I mean, so 85% coverage comes from cellular telephony. If you look at satellites, you can get basically 100% coverage. The question is are there economic models that will allow everybody to connect? Satellite coverage is relatively expensive. So for some people, if you just look at the distribution of purchasing power parity, even though they may have access, there's no economic means for them to get connectivity.
Yeah, Raul Katz, I guess piling up on the prior two interventions, as you said, the issue is economic because the issue is of a competitive model. Because I look at Brazil, and my numbers say, well, we have 91% coverage, 3G coverage, 91% of Brazil, which means it's pretty good. So, but the issue is like 50% cannot afford because prices are too high. So the issue, as you say, is economic, is not technology. Is how do we devise a competitive model or a regulatory model that enables prices to come down in order to make it affordable? So aren't we making a mistake as to where to focus?
I don't think so. So I think your point is actually commensurate with what we're focused on. So the research is on the 15% that have no access. Everything else is about economics. So that's why I mentioned that we're partnering with operators to figure out new economic models to provide access for those who do have coverage, or any other mechanism that people can get access.
Thank you very much.
Next panel, panel number 2. Come on up.
No, Corey. The name, please. Should be right there.